Now this podcast is for real examples about normal distribution. So when you read the questions, make sure you know these important quantities, the 0.75 target value, 0.74 that's low specification limit, 0.76 upper specification limit, and mean 0.73, standard deviation 0.004. So question A, between the target and the mean. So we formulate this as probability 0.75, that's the target value, less than diameter, less than mean 0.753. So the formula we use is equal normdistribution. So you put 0.753, then mean 0.753, then standard deviation 0.004, then logic value 1. Minus normdistribution, then target value 0.75, comma 0.753, comma 0.004, then 1. Okay, let's see if any missing for the formula. It looks okay, so press enter. So the probability is about 27%. B, probability between the low specification and upper specification. So this is same as the part A. So we use the formula equal normdistribution. Your upper specification 0.76. The mean 0.753. Then standard deviation 0.004, 1, minus normdistribution, then low specification 0.74, mean 0.753, standard deviation 0.004, then 1. Let's check the formula, everything is correct. So C, probability when diameter above the upper specification. So we formulate the probability diameter greater than 0.76. So we use the formula equal 1 minus normdistribution. Then you put 0.76, then mean 0.753, then standard deviation 0.004, then 1. Okay, so yes. So question D, about which value in diameter will 93% of the ball bearings will be? So we formulate this question as a probability diameter greater than question mark equal 0.93. So we know 0.93 is probability upper tail. So what's the diameter? That will be equal NORMINV. We know probability, we want to find out diameter. Probability will be 1 minus 0.93. Then you put mean 0.753. Then standard deviation 0.004. So if the diameter is 0.747, then the probability is about 93%. So this example, every time we select sample, we only select one ball bearings. Now the second part, we said if we select 25 samples, and then what is the sample mean? So question number A said the sample mean will be between the target and population mean. So we put formula as probability 0.75 less than sample mean, diameter mean less than 0.753. So we use the formula equal normdistribution. Put 0.753, then put mean 0.753. Now standard deviation. Standard deviation is no longer 0.004. According to central limit theorem, standard deviation are means equal 0.004 divided by square root SQRT, sample size 25. Then logic value 1 minus normdistribution. Then you put target value 0.75, comma, mean 0.753. And then we get standard deviation 0.004 divided by square root SQRT 25, comma 1. So be careful the change of your diameter, standard deviation. Now part D, the sample mean will be between the lower specification and upper specification. So this question will be formulated as probability of low specification 0.74 less than P mean less than 0.76. So we use the same formula as previous questions. So we say this is equal normdistribution. We put 0.76, comma 0.753, comma. Be careful, standard deviation is 0.004 divided by SQRT 25, and comma 1 minus normdistribution, low specification 0.74, comma, mean 0.753, comma, standard deviation 0.004 divided by SQRT 25, and then standard 1. So in almost 100%. Question number C. The sample mean will be above upper specification. So with the probability, the D mean greater than 0.76 upper specification. So now this is equal 1 minus normdistribution. So you put 0.76, the mean 0.753, then standard deviation 0.004 divided by SQRT 25, then comma 1. so almost 0. Now this shows 0. If you want to get real value, you can increase decimal value. Oh, it's 0, 0. Now D, with a 90% of sample mean diameter will be above that value. So we are probability D mean greater than what value, you will get probability 0.93. So the question mark is equal NORMINV 1 minus 0.93, comma mean is 0.753, and standard deviation 0.004 divided by SQRT 25. So it's 0.75. You can compare to the previous examples. So hopefully you will understand how to solve the problem. Make sure you know how to formulate your questions. You need to know how to formulate this, like the probability, this part. Then you know how to put in the formula.